All right, welcome, ladies and gentlemen. We are in week 14. My name is Brian McLogan, and we are live for another open Q&A. So for this week, I have a couple of identities have come across. It was kind of interesting. I'm not, depending on what everybody's taking, but we have some identity problems. So in this one, we're going to this one I just had to verify the identity. Then we have one we're going to simplify using the sum or difference identities for cosine. Then we're going to do a complex fraction. And then this one was actually a simplifying problem. So we are going to simplify this one. So that was what was going on over there. So then guys, the way if you've ever joined a live stream, and before, basically what I'll do is I'll cover these kind of 4 questions. And then obviously if you guys do have some additional questions, kind of depending on how long the stream will go, then I will maybe take up some of those other questions. These are questions that people or students have submitted to me on my community post as well as on my Discord link. So in the description below, you guys can see the Discord link, and also you guys can, take a look for my community post on my channel. You guys can also go ahead and respond there. So I created the Discord to kind of make something a little bit easier, also for you guys to interact a little bit easier with each other. Please understand, guys, I'm not on Discord every day, every minute answering math questions. But the idea is really to have you guys have another avenue for you guys to get your questions answered. I will say, again, just like with the live streams, the more specific you can be with like where you're having trouble, the easier it is for myself or anybody to be able to help you. So if it's something that you don't know where to start, or you're not understanding how to set something up or to finish something, or where the work doesn't make sense, those are some of those comments that you can add that really kind of bring a really kind of full circle into where you're struggling with. But these are some problems that I'm just going to work on. I made this one up, so who knows what this one's going to look like. But these are problems that I'm going to cover with you guys in the week 14. And I know that a lot of you guys are also getting used to this distance learning. This is something that I've been doing, or at least doing the open Q&A since the beginning of this year. So, but a lot of times I was answering questions for students. Obviously they had their homework, but they're going into school. And now it's kind of weird because I'm like, all right, yeah, I'll answer your questions online, but then also you're just staying online, for a majority of you, then staying online because you're not going to school, which is a crazy thing to think about, a sad thing to think about. But, and also just a little bit of reality. But I do see a lot of you guys have joined on. So I do want to say thank you for joining in. So Ficano, nature is awesome. Morpheus, James, hello. Ashlyn, J Dig. Arsian, good to see you guys. Daniel, Wendigo, and Addie, of course. So yeah, so I'll kind of get to some of your guys' questions. In general, I like to kind of keep these open Q&As on Sunday really heavily math oriented, meaning I just like to do your math problems basically, and give you some explanations to help you guys out. My goal is not just do random, just to do math problems, but really kind of get you over the hump as far as what you're not understanding. However, I do also added in, since we've been doing this distance learning, so many of us, I did add in an extra live stream on Wednesdays, where it's still geared towards the math, but it's a little bit more sectioned as far as just kind of talking about, the teaching and the learning perspective with distance learning and how things are kind of going in my own classroom and what are some things that I'm doing and some advice around there. And then obviously if I have time, I've answered some questions there. But what I do guys is every time I go or every time before I go live, I'm always looking at your questions. So please make sure you guys are submitting them. And again, I do appreciate you guys in there. Are these questions pre-calculus or calculus? These are these are all questions you could see in part somehow in or use at least in calculus, but I'm seeing a lot of these would be something you'd see in like a trig or pre-calculus kind of course more commonly. The demos are tough. Yes, identities are tough. So, that looks like it's going to be the theme for this chapter or for today. So that's perfectly fine. So we'll go and get theirs. and weird in my world. How are you? Brian, are you a math teacher? Yes, I am a math teacher. I have been a math teacher for 14 years now at the same high school, doing the same thing. And I've been recording my lessons inside of my classroom since 2010. So, I've never gone over to the online learning model. I've never actually been, even though I record myself, I don't do flipped classroom. Really, my videos have really just been there as like an extra resource for my students. So I never did anything. I just kind of created the videos back then to have my students have something extra, and then I just never stopped creating videos. And so but I haven't had to rely on my videos until now. And that's where I've had a big learning curve as well with myself as far as teaching, because now I actually have to rely on these videos that I'm presenting to my students. So at least fortunately this year, I have been recording full lectures in my house rather than in the classroom. So I still record myself when I teach, but I've also been recording some full lectures. So that has actually been really helpful. And thankfully, I started doing that this year. So I do have something to fall back on. But mostly, yeah, just teach. I only teach pre-calculus for this year, and that's also been very, very helpful. Especially now, because I don't really have as much I only have the one course to prep. When teachers have 2 or 3 preps, you got to think all the stuff that they're doing for one class, they got to do completely again for the other class, teaching different material. And especially once you've been a teacher for a while, you kind of get used to teaching and organizing content and everything like that. But when you have double preps, I mean, that's double the amount of work that you have to do for those classes. Doesn't matter if you have 1 or 2 of them, you have to, get them their work and everything all set up. Use the missing measures. Okay, guys. So what I'm going to do is I'm going to get through these 4 questions that I have. And then what I'll do is I will come back to your guys' questions. Again, feel free to add in any of your questions, or you guys can also go ahead and go to Discord after the chat, and hopefully you guys can, I'll jump in there as well and try to see what other questions I can answer. And then maybe hopefully some other people will be able to chime in as well and help you out. But nature is awesome. That is a good question. I am actually going to answer your question on Wednesday. So I will get to that question on Wednesday because I really like your question, and I think it should just be the name of my live stream for next Wednesday. All right, so let's go and get started in with the math, verifying the identity. So, all right, so basically when we have a verifying identity, we want the left side to look like the right side or the right side to look like the left side, and we basically want to use our trigonometric identities to do that. So a couple things stand out to me. First of all, whenever I see a trigonometric function squared, I immediately am thinking of my Pythagorean identities. And the most famous Pythagorean identity of them all is the sine squared of x plus cosine squared of x equals 1. I'm not going to go ahead and to prove it, but it is very simple as far as an understanding with the proof, and to be able to understand that this is an identity. Basically means sine squared plus cosine squared is going to equal 1. So what I recognize here is if I just rearrange this problem to sine squared of x plus cosine squared of x plus cotangent squared of x, right? We don't really actually need to rewrite the right-hand side. Let's just leave it there. But if I just rearrange terms, you can see I have sine squared plus cosine squared. So that's going to equal 1 plus cotangent squared of x. Now again, that still doesn't equal cosecant. But the cool thing about this Pythagorean identity is we can actually rearrange, or we can actually rewrite this identity to include cotangent and cosecant. So all I simply need to do is if I took this identity and I said, all right, if I divide everything by sine squared, then that is not going to change the equation because I'm applying the operation to every single term or expression inside of that equation, right? So I'm still keeping the equation. This equation is still going to be equal on the left and the right-hand side because I'm dividing everything by sine squared of x. But now I get 1 plus cotangent squared of x, right? So sine squared over sine squared is 1. Cosine squared over sine squared, well, cosine over sine is cotangent. So cosine squared over sine squared is going to be cotangent squared of x. And then equals cosecant squared of x. So now you can see that 1 plus cotangent squared is equal to cosecant squared of x. And that's exactly what we wanted to have on the right-hand side. So you can see in this case, we just rearranged them. We applied the Pythagorean identities to go ahead and simplify, and then also to be able to rewrite that left side in terms of cosecant. All right, for the next one is using the sum and difference identities. So in this case, we need to understand that we cannot evaluate the cosine for a negative 105 using the unit circle. So typically when we're evaluating trig, if we're not using our calculator, we're looking at the unit circle, right? But the unit circle is only going to be angles that are in terms of 30 and 45 degrees. And 105 degrees is not divisible by 45 or 30. So what we can do though is we can rewrite this equation as, well, we could say negative 60 degrees. What the heck's going on with my thing? Negative 60 degrees plus a negative 45 degrees. Okay, so basically if I add negative 6 degrees, now I know on the unit circle, I can evaluate the cosine of negative 60. And for negative 45, I can evaluate the negative 45 degrees for cosine as well. Well, so really what I'm trying to do is I'm trying to evaluate the, let's not write that over there. But what I'm trying to do is I'm trying to evaluate for the cosine of u plus v. So really what I'm doing is if I take this angle that you can't evaluate from the unit circle, but if you can break it apart into either the sum or difference, then you can use what we call the sum or difference formulas. So if I have cosine of u plus v, I could rewrite that using the formula, which is cosine of u cosine of v minus the sine of u times the sine of v. So now what I'm going to do is I'm basically going to say, all right, well, let's have this be u and that have v. And now let's just plug these angles into this formula. So therefore I'll have cosine of negative 60 degrees times the cosine of negative 45 degrees. And that's going to be minus the sine of 60 degrees, or I'm sorry, of negative 60 degrees. And then it's going to be times the sine of negative 45 degrees. Okay, now obviously I still need to be able to evaluate here on the unit circle, right? So if we go to the unit circle, we know that negative is going to be going down in our fourth quadrant, so it's going to be somewhere down here. We're going to have a 60 degrees and we're going to have 45 degrees. Okay, so that will be, let's say, negative 45 degrees. And let's do this one as a negative 60 degrees. Okay, so if we have negative 45 degrees and a negative 60 degrees, remember for those coordinate points, if you hopefully at this point, you should know the first quadrant. That's a horrible, bad first quadrant. But hopefully you should know the first quadrant and those coordinate points. And really all we're doing is just doing reflections. So it's going to be the same point as the first quadrant, but now it's going to be in the fourth quadrant. That means the y coordinate is going to be negative. The x coordinate would be positive. So in this case, I'll have square root of 2 over 2, comma negative square root of 2 over 2. And then over here, don't want to forget this one. This is going to be a positive 1/2 negative square root of 3 over 2. All right. So if you guys can just remember, again, just doing a quick little review of unit circle evaluating, you know, cosine represents the x coordinate and sine represents the y coordinate. So for the cosine of negative 60, that's going to be 1/2. I'm going to put them in parentheses so I just remember that I'm evaluating. We have cosine of negative 45 degrees, which is going to be the x coordinate, which would be square root of 2 over 2. Sine of negative 60 degrees, which is going to be a negative square root of 3 over 2. And then we have the sine of 45 degrees, which is going to be a negative square root of 2 over 2. All right, so now when you're multiplying, again, it's just going back to like, you know, pre-algebra days, multiply the numerator times the numerator, divide denominator times the denominator. You could simplify this by factoring out first of all, but I'm just going to go ahead and multiply this once so we can get one answer here. So we have square root of 2 over 4. And then here, let's see here, we have a negative times a negative, and that would be a positive, but then we're going to make that a negative as well. Again, so that's going to be a negative. Negative. What am I missing here? Something that's positive times a positive. And that's going to be a negative square root of 6 over 4. But that doesn't seem right. Let me see if I did this. James is writing, when graphing a circle, shouldn't x and y coordinates be in the radius or radii? After all, pi defines the relationship between the arc length of 100 degrees and its radius. Let me just double check my thing. I have that for the y coordinates. Cosine. Oh, yeah. Okay, never mind. Yeah, so that'd be fine. Sorry, I was just doing some brain thinking on my thing. So yeah, we'll just go ahead and do there. Obviously, based on your problem, you could still have some different variations going into the, factoring out certain terms and stuff like that. But in general, that would be your answer. And then, you could also like factor out a 1/4 and like there's a lot of different variations we could go from here. But for the purposes of just keeping things simple, I will just leave it up to there. Okay. So for the next one is, let's go and get away from the identities. Actually, let's continue on the identities because then at least we'll be done with the identities and then we'll get into the complex fraction. All right, so for the next one, we have secant of x times cosine of negative x plus tangent squared of x. Now in this one, the goal is just to simplify. So with the verify, we were trying to make the left side look like the right side. The other one we were evaluating, so we're looking for a value using an identity. And this one, they're just saying, well, pick some identities that's going to simplify this. And typically when we're simplifying, we're trying to get it down to a single number or a trigonometric expression. So the first thing I recognize here is I have the cosine of negative x, which is going to be a negative angle, or it's going to be my even odd identity. So applying my even odd identity, the cosine of negative x is simply just the cosine of x. Okay, again, that is using my even odd identities. Then I recognize that I am multiplying secant of x times cosine of x. Now again, remember, secant and cosine are reciprocals of each other, right? So now we can use the reciprocal identities to say that secant of x times cosine of x is just going to be 1. So I have 1 plus a tangent squared of x. Once I see that squared, I realize, oh, that's making me think again of my Pythagorean identities. Well, I can't be sine squared of x plus cosine squared of x. And when I divided by, what was that? When I divided by sine, I got the cotangent squared and cosecant, but I want to get tangent. So what if I divided by cosine? So let's go ahead and do that. So if I divide by cosine, everything by cosine squared, sorry. Oops, what am I doing that for? Okay, so sine squared over cosine squared is going to be a tangent squared of x. Cosine squared over cosine squared is going to be a positive 1. And then 1 over cosine squared is going to equal to secant squared. So now you can see that 1 plus tangent squared is just equal, I guess I still should use a equal sign. That's going to equal to secant squared of x. So you can now see I took this very large expression and I simplified it down to one trigonometric function. All right, last but not least, ladies and gentlemen, is question number 3, at least for the pre-recorded ones. I will definitely stay on for you guys and answer some of your answer some additional questions for the stream. So if you guys do have some questions, go ahead and add them in there. I can't get to everything. I'm not going to be able to get to everything, but I might be able to answer some of your questions. So if you do have something that you kind of maybe jumped onto the live stream mid-roll, or you weren't able to submit your questions on Discord or the community post, feel free to add them there. I'm not going to be able to go back to those sections, but you can always add them into the chat and I will see what I can do. All right, so for the last one is way too many fractions. That's the way at least I described it this year. I said, guys, that's just too many fractions. we have to eliminate these fractions. So the way that I like to eliminate the fractions is understand this basic concept. You know, if I had like 1/4 divided by, or 1/4 plus, actually this is, yeah, I didn't really choose the one. But if I had 1/4 times over 3, and let's just say, you know, 1/3 plus, I don't know, 3/4. Okay. Now you could easily add these fractions up, right? There's nothing wrong with combining them. But if you also think about this, if you just multiplied everything by 12, okay? Now, why is 12 such a special number? Well, 12 is a special number because that's what we call our least common denominator, because 4 divides into 12 and 3 divide into 12. Now, when you multiply everything by 12, you end up getting this 3 plus 4 over 4. Actually, you know what? Let's just write. Yeah, let's just do this. There you go. So 4 plus 3, right? Now, obviously, I know this is the exact same numbers over themselves. Actually, here, let's do this. Do it this way. I'm making up the problem as I go. So now it's not going to be exactly the same. Okay, now you just couldn't like divide. Now you couldn't just recognize they're exactly the same. But again, my point is now I've eliminated, right now I had two fractions in the numerator, 2 fractions in the denominator, and a big fraction, right? But just by multiplying by the LCD, I now only have just one numerator and one denominator. And that's our goal when you're dealing with these complex fractions. You have fractions in the numerator and fractions in the denominator. That's what makes them complex fractions. So you could combine operations, and sometimes for some problems that is not a bad idea. Like for this one, you know, it wouldn't really be that bad to just go ahead and combine them, right? Depending on how well you are with fractions. And in this problem, and some problems that I've seen, it's just easier to, you know, simplify the numerator and denominator and then divide. But in this problem, since I made it up, I have no idea what that would look like. And it doesn't seem to be a great approach. So what I'm going to do is I'm going to multiply by the LCD. Now the LCD 12 came from 4 times 3. Because 4 and 3 both divide into 12. So obviously the LCD has to be a multiple of both 4 and 3. So it's not always the case. Do you want to just multiply the denominators to find the LCD? But a lot of times that does work. And I'm not going to go into all the scenarios of when and when it doesn't work. But when you're dealing with polynomials, that is even more often to be the case. So just to keep things simple, I'll say the LCD in this case is going to be the product of the two denominators, right? And now I'm just going to multiply this times everything. Now you got to make sure you multiply this by everything. So when you multiply, so therefore you're basically, let's just rewrite it. Let's just write over here, x minus 1 times x plus 2. So I'm going to multiply everything. So here, to save time, I kind of use these arrows, right? And you can do that as well. There's a lot of different ways to write it. And you could also rewrite everything. But sometimes, guys, that's just a lot of work and a lot of things to write. So the nice thing is when you multiply this, though, since x minus 1 divides into x minus 1, right, these are going to divide out. So I'm just going to be left with a 5 times x plus 2. Over here, the x plus 2s will divide out. So I'll be left with a 3 times x minus 1. Over here, I have x plus 2s divide out. So I'll be left with a x times x minus 1. And then over here, my x minus 1s will divide out. So I'll just be left with a x times x plus 2. Okay, so now it really just kind of comes into simplifying using distributive property and then combining like terms. So we have 5x plus 10 plus 3x minus 3 all over x squared minus x plus x squared plus 2x. All right, and then that equals 8x minus 7 plus 7, going crazy here, all over, let's see, x squared plus x squared is going to be a 2x squared, and then negative x plus 2x is going to be a plus x. And then I'm not really seeing anything else I could further simplify from there, so that's where I would just leave that problem. All right, so what other questions do you guys have? Keep them simple. And not a lot of words. That means like word problems, I don't get to word problems because it's just too much stuff to kind of cover here on the live stream. And make sure I understand every concept. So Thanos Maddox, thank you very much. Addie. In that case, Blade Lewis, Veronica, Orlando, thank you very much. Man, you guys are coming in. All right. Are you allowed to ask a question? Yes, you may ask a question now. Is a great time. Yeah, typically, I mean, I teach rational functions in pre-calculus. It is a little bit more for as an algebra 2 type question, but it is something that comes up a lot in like pre-calculus, or at least a lot of the concepts is very important for calculus and pre-calculus. So I end up spending a lot more time in pre-calculus than I previously used to in pre-calculus. It used to be something I would just kind of cover like briefly, but I've figured out that students really, really have a tough time with that, and they don't really get the necessary practice in algebra 2. So that's why I kind of cover it a little bit more. Did you see my comment on the law of sines video, Justin? No, I do not recall your law of sines, your comment from the law of sines. How do you create a recursive format to an explicit and vice versa? I do. It's been a while since I went through the sequences of series. So it's definitely something that I would need to go back and revisit. So I'm not going to be able to cover any sequences or series. It's just not something that I've recently done in my courses. And that's why a lot of times with these live streams, I know it can be confusing, but I also get not confusing, but annoying because I kind of cover a lot of the same topics. But again, I don't want to also waste a lot of your guys' time with me thinking or drawing up or researching, to remember a lot of the things that either I've never taught, maybe I took it in my schooling, or something I've taught and it's been just so long ago that it's going to be a while for me to be able to like think through the problem and just make sure my explanation is going to be on point. Well, you're very welcome, Veronica. I'm happy to help you. All right. Let's see. I could just wrap my head around the ambiguous case regarding the side. Okay, I can talk about that. Nobody likes the ambiguous case. That one is something difficult. All right, I will definitely talk about that, Thanos, for sure. It is a confusing topic, so I think that definitely warrants me talking about some stuff. Thank you for the videos. You're very welcome, Justin. Thank you. French fry, you are very, very welcome. And thank you, Addie, for always being right on cue with the links and being able to help everybody out get used to the stream and get used to the stream and knowing where to kind of get their questions answered. I really do appreciate it. All right. Thank you for your videos. They helped out a lot. Can you find the videos of all these things? Yes, you can. Last time you have a decimal, do you leave it as is? All right, Justin. So let me just kind of read. And Adam, I see your question, but I'm not going to go through identities. I've made that mistake one time where I tried to work through the identities. Doing identities in front of people on the live stream, unless I like visually see the answer, I don't want to cover it because again, you can just go you can do these identities. You can go in so many different directions, and it is something a lot of times where you, due to the distractions of like the lights and going on live and doing it just doesn't work. I tried to do it in one, and then there was one I got stumped, and then after the live stream, I did it. I'm like, this was so easy. How did I not do it? I'm like, of course, I'm going live. There's so many other things going on. So that's why, a lot of those questions too, if it's not something that I know, I feel comfortable being able to give you an exact explanation of what I'm doing and why I'm doing it. Cause I can really kind of see that pathway. I don't really see the value of, trying to go through it on live stream. However, if you do submit that to me, in my community post or on Discord, then I will see what I can do as far as replying back to you on there. What's that? Oh, thank you, Veronica. That is very, very nice of you. I really do appreciate that super chat. Thank you so much. I really, really do appreciate it. That does mean a lot. I know my videos have been able to help, and I really appreciate the kind gesture and then as well the lovely little emoji showing up. So I do appreciate that, and it is the reason why a lot of people were surprised, or maybe not surprised, but for my week 14 and oh, you've been going live for roughly 14. Well, I'm like, no, I just wanted to start counting the weeks for for this year. But yeah, I've been going live for like all this weeks, and I've been answering your guys' questions, and that's what I want to make sure that I'm here for. And it's just kind of not as fun now that you guys are going back to online teaching. It actually was a little bit better kind of being like, hey, I'm here for you online, and then you guys go back into your like normal like classroom environment and like learning that way. And now it's just everything's online. And I think it takes off that little like novelty of like math instruction online. Or at least with the live stream, like, I'm doing this now every single day with my classes, teaching, going over math with my students. So it's not as fun now to get the lights and go, and get on the camera with them and teach, because now that's actually my reality as well. So, but I really, really do appreciate that. Thank you again. All right, let me just go. So I'll go and cover ambiguous case. And then Justin did have a question. What was that question? I need help adding polynomials to find the perimeter. Well, Evie, just basically, you can see I kind of did some adding polynomials here, just combining like terms. Make sure that your exponents have to have the same base, meaning x or x, x or y or whatever may be the case. And they have to have the same exponent, meaning the power. So these are x's to the first power. That's why I can combine them. These are x squareds. That's why I can combine them. And then obviously your constants, your numbers, you can just combine them. And just remember when you're combining monomials that you just keep the base, the exponent, like the same x, but then you're just combining the coefficients 5 and 3. Finding the perimeter of polynomials. I mean, again, the perimeter, I don't know what you mean of what type of shape, because they're all going to be different. But again, would just be combining like terms. That's the main thing you need to see. Our main thing you need to know how to do, which is what I kind of covered here. How would you direct the min and max values of quadratic? There's many different ways to do that. Why is there a circle graphed in factors of 1 and pi, but not in radii? Graphed in factors of 1 and pi, but not in radii. James, I don't know. I'm not sure to really answer your question. That's something I'd probably, again, same kind of thing. That's something I have to like look into, think about a little bit more, and not something that I have like a quick, be able to answer right for you. So I'd have to just really kind of digest really what your question is coming from, and then really kind of be able to provide a response in more depth, for you on that. All right. But Justin had the co-function of that. I've wanted to, yeah, okay. Find the law of sines with an angle having a decimal. For the law of sines with an angle with a decimal, do you leave it as is, or do you put the decimal in minutes, seconds? It really kind of depends, Justin. I wanted to get to your question because I read it and I didn't get to it. You'd really just want it. It really kind of depends on what your teacher. I don't require my students to put it in degree, minute, seconds form. So I would just leave it as a decimal. But again, it really kind of depends. Charlie asks, how do you determine the max and the min of the quadratic? You got to find the vertex. So there's many different ways to find the vertex. You can rewrite it using vertex form. You could graph it and find the maximum or the minimum points. Or you could use the formula for them, like to find the axis of symmetry, opposite of b divided by 2a, which will be your x coordinate, and then plug that value into your function to find the y coordinate. So you could also use that instead of using completing the square. And remember, completing the square would be the h comma k. Can you cover finding the perimeter? Hopefully that helps you out. Can we problems with the discriminant? I'm not going to go through and get another problem with the discriminants. Do you have questions on like what the discriminant tells you? Or what do you mean with what is the discriminant? Or doing problems with the discriminant? Because basically the discriminant is going to be what is the radicand of the quadratic formula. And then what that's going to tell you is the type of solutions you're going to have for a quadratic. So basically discriminant b squared minus 4 times a times c. And really that's going to tell you, since you're taking the square root of that value, if that's value negative, you're going to have no real solutions. If that number is a square number, you're going to have 2 rational solutions. If that number is a non-square positive number, you'll have 2 irrational solutions. And if the discriminant is 0, you will only have 1 solution. But it's kind of a lot. To kind of go over and explain all of those types. but you just really kind of want to make sure you understand what the discriminant is, and then where the B, the A, and the C, where those come from the equation in standard form. I was are you bored? Yeah, maybe bored. That's a good one. Math gives power. I am using a green screen. I'm not using OBS. I have a Mac, so I'm using Ecamm. I did use OBS when I first started doing some live streams. I just didn't really like it as much. But I've seen they've come out with a lot more updates, and so therefore it is, and I know some people like really enjoy it. So I just didn't really connect with it. And then once I got into Ecamm, which is paid service, and obviously it's only for Mac only, but I just really, really liked Ecamm. And so that's kind of where I have, just stayed with, just because it's made my life easier. My high school is Mandarin High School in Jacksonville, Florida. Justin, I'm not going to get into this. I was already called out by somebody last time, but as far as the quadratic formula, where it comes from is basically if you just take the standard form of a quadratic and complete the square for ax squared plus bx plus c, that is how you'll be able to go and get the quadratic. I'm sorry. Yeah, as far as the line, completing the square, you'll get the quadratic formula. Yeah, that's right. But it's a little more. Is it completing the square? What am I going? I'm having a brain fart. Now you remember. I'll just go with that. And then if I misspoke, then I'll just call it is what it is. As far as the quadratic formula. But yeah, b squared minus 4 times a times c. I believe if I remember correctly. I know I have a video on it, creating the quadratic formula. All right. Okay. Yes, we are getting into there, guys. And again, just a reminder, I'll cover this last question. Victorious, I'll get to your question in just a second. But yeah, just a reminder, guys, I will be going live again on this Wednesday. I will not make it on a community post, but I will jump onto Livestream. I will answer some more of your questions, a little bit more kind of geared towards the, a little bit more geared towards to kind of like the learning and distance learning kind of section. The learning as well as the teaching side. But then also, if you guys do have some math questions, I'll always be able to add them in there. And then what else was I going to talk about? So yeah, that'll be on Wednesday at 9 p.m. Eastern Standard Time. And then on that Wednesday, I will post the stream for that. I will post that ahead of time. And then Victorious Warrior was saying, what platform do you teach your students? We're on Microsoft Teams. So that is what our school district uses, is the Microsoft Teams. But then I create my notes in Google Slides, and then I save them as PDF. So I record them. Just kind of like I'm recording with you guys, but I do use a paid software, ScreenFlow, to record my slides on Google Slides, and I use the Notability app. This is the whiteboard app that I'm using. So therefore, once I create my slides, I download them as a PDF, and then I upload them. So I share them with my students as a PDF, and then I can upload the PDF into the Notability app, and then I can write on them and record my lessons for my students. All right, but you guys are getting a lot of questions, and I'm not going to get to them. I do apologize, guys. But please make sure, if you want to go ahead and add your questions into Discord, I will get into there tonight and tomorrow, just to kind of like answer questions that I can. But also I've already seen a lot of great interaction with people helping each other out. So if I'm not going to be able to get your question, which is more likely, then there are other people that are answering other people's questions, and just to be nice and help people out. So please, if you are asking a question and you see something else that you can contribute to, help somebody else out. This distance learning is not something that everybody is ready for. And it's very difficult. Math can already be very difficult for a lot of students and school, and there's a lot going on. So if you're able to answer any questions from somebody that posts in Discord, please help them out, because it does mean a lot to them. And it does mean a lot to, have people know that there are people that have been where you have been, right? You know, I mean, I can't remember. There was something that, you know, everybody has gone through algebra 1 or like the same math. Like you don't get to being, you know, learning like the calculus if you didn't originally already go through some of those early, you know, classes and those earlier problems. You know, so don't feel bad about asking a question, even if you think that, you know, the people in there are helping you out or way smarter than you. Like we've all gone through the same process. So either way, let's go ahead and wrap up the stream with just kind of covering this ambiguous case form. And so what I'm going to do is I'm going to kind of cover, let's see, how can I cover this in 5 minutes to make it make sense? So, all right, because I usually spend like a good 45 minutes on this. So let's condense a 45-minute lesson, not 45 minutes, probably like 30 minutes. But let's maybe condense a 30 minutes. Well, actually, it's really all the whole class. So let's just, to make it cool, let's just say 90 minutes into a 5 minutes lesson. All right, the first thing is, let's go into talking about, let's say we had an angle, and here's our angle A. And then we had a side length here. Let's call this B. And then we had this as our H. Okay, so let's say we had a triangle here. Now, based on this triangle of this angle A, you can see I have the opposite side. And actually, let's call this a right triangle. So since it's a right triangle, we can use our trigonometric functions. Now, if I want to create a trigonometric function for this, I could say I have the opposite and I have the hypotenuse. So the function that works for opposite and hypotenuse is the tangent. So you could say, sorry, not the tangent, the sine. So you could say the sine of A, right, is the comparison of the opposite side over the hypotenuse. So H over B. Opposite over hypotenuse. Yeah, okay. And now really H represents the height of this triangle, right? Okay, so let's just say here that if I wanted to solve for this, then I could say H equals B times the sine of A. Okay, so remember that. H equals B times the sine of A. All right, so there is a triangle. Now that is a right triangle. And when you study the law of sines, law of cosines, what we use is what we call oblique triangles. So the study of oblique triangles is basically triangles that do not contain a right angle. Now, let's go ahead and say, all right, so if it can't be a right angle, right, then it has to be either, then H cannot be the height of my triangle. Therefore, it needs to either be bigger or smaller, right? So, and then also this is not going to be a right angle. So this is going to be, you know, either it could be acute or it could be obtuse. So let's kind of take a look at how that would look. So here's my A. Let's go from there. Right? I could have a, let's say if it's, let's make H, or let's make this smaller. Okay, and let's call this little a. And then, so here's H. Now, in this case, when I have my A is less than H, okay, so here's the height, right? That creates your triangle. When A is less than H, you see that there's no way a triangle can be formed, right? If I rotate this, because again, the only thing that we know is this is what we call our angle side, right? Haha, it spells a bad word. But that is why when we have side angle or angle side, whatever you want to call it, that is why we create our ambiguous case. We do not have enough information to know exactly what our triangle looks like. So now, if we had angle side and our third side, H, was actually the height of the triangle, meaning it was equal to B times sine of A, then we would have a right triangle and we would have one case. And that's actually, if you remember geometry, we use that HL theorem. Now, in this case, what if my A, so what if the problem I was given, I have my A and I calculated the height of the triangle. So if I was able to calculate what H would be, which is again, what is H? It's just B times the sine of A. So B times sine of A gives you the triangle, or gives you the height of the triangle. Now, again, if the third side that I was given, the opposing side of my angle is less than my height, then no triangle can exist. There's no way for me to draw a triangle because, again, if I extend this side here, right, there's no way that when A is going to be less than H, there's no triangle. It's impossible. Okay, so let's go on the flip side then. What about if I have this exact same triangle again? So I have, here's my A, here's my B, here's my H, right? What about if I had this side length? It was huge, like this big. Now, obviously, I'm not going to have a triangle here. That's not going to work, right? But couldn't you rotate this triangle back up to there? And then you can see that there's only one triangle that exists. Now, again, if I keep on rotating this, and again, let me just kind of use maybe a different marker here, blue. But if I continue rotating this, and again, please be nice to me on my illustrations. But you recognize that, like, since A is larger than B, right? Obviously, it's larger than H, right? That's obvious. But A is also larger than B. So therefore, if you rotate it this way, it's not going to create a triangle. But if you rotate it back, it eventually marks up with this side. Because again, we have angle, side, side. So again, that only creates one triangle. So in this case, when we have A is larger than B, then we're going to have one triangle. Okay? And then the last one, which is the ambiguous case, is why we have two triangles. Now, we don't really have two triangles. The problem is we don't have enough information to know which triangle we have. And that's kind of the important, I think, some of the distinction with the ambiguous case that gets students confused is I think that it creates two triangles. It doesn't create two triangles. We just don't know enough information on what the triangle looks like, right? So the only thing that's helpful is when our third side, our opposing of our A is the height. When that side is the same as the height, we know we have a right triangle. We know exactly what the triangle is going to look like. When A is less than H, we know that no triangle exists. When A is larger than B, then obviously, I actually do need to phrase this. When A is larger than B, but also, because actually it's an inequality, A is going to be larger than H. And my inequality is not really written so well. B is greater than H from there. So yeah, obviously A is going to be larger than H, but it's going to be less than B. And I apologize, guys. I don't have my notes. I just taught this and but hopefully you can look at this. I just want to get to the explanation portion of it. So I know my inequality is not great. But let's go and look at the third case. So the only other situation we have not dealt with is what about when A is larger than H, right? But not bigger than B. So let's go and draw that. Let's draw that situation. Okay, so here's A, here's B, here's H. All right. Now let's pretend here's A. Let's put A right here. Okay. Now in this case, A is obviously larger than H, right? Because as you rotate this, go back to my other color. As you rotate this, like A would be all the way down there, right? So it's obviously going to be larger than H. But as if I keep on rotating it here, you can see it's going to intersect. And therefore, what I can do is I can create another triangle. So now what we have is not only do we have the red the red acute triangle, but now we've also created this red obtuse triangle, which would look something like this. And again, guys, just for the sake of time, I apologize. I'm trying to get this done. But the problem is we do not know which triangle is which. So if we're given the information A, B, B, and A is bigger than H, but now it's less than B, then we have two triangles. Or at least we have the case where we don't know which triangle is which. This is what we call the ambiguous case. We don't have enough information to determine which is the correct triangle. So hopefully that answers your questions. It took me 10 minutes to explain it rather than 5, but hopefully that was at least helpful for this. Very good. All right. So sorry, guys, if I did miss your question. But again, I do have a link into the Discord. And my goal is to keep on getting more and more people on there asking questions, as well as more people helping each other out with their mathematics. And then also, guys, I will be live again next week to answer your questions. But again, guys, if you want your questions to be answered, the best bet is to get those questions sent to me ahead of time. I make a community post every Saturday. So therefore, you can respond to your questions on that community post, or you can submit your questions on my open Q&A tab on Discord. And I do look at them every single time before I go live, and that is where I get my questions. I will also be going live on this Wednesday to help you guys out with going over the distance learning, to answer some more of your questions and to help you guys out there. So, all right, guys, it has been great. Thank you so much for joining me. I wish you guys another great week of learning, distance learning style. But I look forward to being there to help you out with your math. So have a great week, guys. I'll talk to you soon. Cheers.